Okay, hi everyone. Welcome to PH110 vectors lesson, last part. So last time we did the first part that we talked about to calculate a lot of things under vectors. So to calculate the magnitude, to calculate the angle, right? So we did all those things by analytical method. So we remain with the last part, which is calculating or rather finding the vector product, which is also called the cross product. Then another thing, finding the scalar product, which is also called the dot product. Okay. Then the unit vector. Okay. Unit vector. So 1, 2, 3. These are the things that remained under vectors, and we're going to find them. All right. So let's proceed. We shall do the question, and it's good that the question that is going to be asked is going to cut for all these three things. Then from there we go to chemistry, and also we do the last part. All right, so I've got the question here written here. Hope you can see the question. All right, it's clear. So the question is saying, given two vectors a and b. So a has got j plus 2i, then plus 3k. So this is I, this is j, then k. So meaning it's in x, like remember what we said in the notes to say I symbolizes x, then j symbolizes y, then k symbolizes z. So a, I, 2j, 3k. Then b, vector b has got 3i, then plus 2j, then plus 3k. So now the question is, 1, calculate the vector which is perpendicular to these two vectors. Then question 2, find the angle between the two vectors. Then C, the unit vector. All right. So let's start. We'll start with calculating the vector perpendicular to the two sets. Remember what we said in the first place in the notes. We said a vector product, when they tell you to say find the vector which is perpendicular, the vector which is perpendicular to the two vectors is the vector product or cross product. So when they tell you, if they want, like they have done here, they cannot tell you to say calculate the vector product. They will just tell you to say find the vector which is perpendicular to the two vectors. So you must get acquainted with this term. You must familiarize yourself with this term. So in short, here we are going to calculate the vector product, which is a times b. This is the vector product. All right, so let's go. Solutions. So the vector which is perpendicular to the two vectors is simply a times b. So now we have been given to say a is this and b is this. How do we find this? We are going to, so one of the things that you must know, guys, is when calculating a times b, it simply means, like in mathematics, the way we calculate the determinant under matrices, okay? The two determinant. So that's how you must calculate here. So how are we going to proceed with this? We're going to proceed it in this way. You say a times b is equal to, you put the straight bars, all right? So when you put like this, then you indicate I, negative j, then k. J always goes with a negative, I always with the positive, k positive. You must master this. Once you put this negative here, you are gone. So when you put like that, then you put the figures in each. So here you're going to say, from the figures, you're not supposed to get the figures from your head. The figures are given here. So this is j, meaning we've got 1 as the coefficient for, this is I. We've got 1 under this. So you're going to put 1, all right, 1, then this is 2. You're going to put 2, then this is 3 under k. You're going to put in 3, all right, then here 3. So you're going to put 3, then 2, then 3. Okay, all right. So when I put like that now, I need now to form something that will help me to find the determinant of two things. So I'll proceed like this. A times b is equal to, here I'll form like this, then I'll say I, meaning the figures that are going to be in this are of I, the ones that are going to obtain from I. Then I'll say plus, I'll say minus, because plus is already here. Okay, plus is already here for this j. So for this I. So here I'm going to put minus. All right, when I put minus, then I put the straight bars for j at the end of it. All right, then from there I'll say plus. This plus is for this k and not this j. This j is more or less like, okay, if you want to let me not confuse you, because you may just get confused. So I'll say a times b. Let me do like this. I'll say I, which is in plus sign. I can put like this. All right, then from there I'll say negative j. At least this will help you, because others might get confused. Then plus k. At least this will help you so that you don't get confused. So that j is just indicated with, because you might think I is the one that had negative, but in the actual sense it is this. So when I put like this, it's up to you. You make the right decision. So now, how are you going to obtain, all right? How are you going to obtain the matrix of this I? So in simple terms, when finding the matrix of a particular letter, you simply hide whatever is related to that particular letter. What do I mean? Here you're talking about I. So in order for me to obtain the matrix of I, I'm going to hide anything that is related with this. Have you seen? When I hide like this, because I is here. So when I hide here, I also hide here. I'm remaining, what can you see? You can see 2, 3, 2, 3. So these are the figures that are related with I, are the ones that I'm going to write in the box. So I'm going to say 2, 3, 2, 3. All right. So these are the ones for I. Then we proceed. We also find now for j. How are you going to find for j? I'm going to hide this, all right, and also this in between. This in between. Hope you guys can see. When I hide this, what am I remaining with? I'm remaining with 1, 3, 3, 3. All right. So I'm going to write whatever that I'm seeing after hiding something. So I'm going to say 1, 3, 3, 3. We are remaining with k. I'm also going to hide anything related with k, because k is here and is related with this and this. So I'm going to hide also. Hope this is making sense to you guys. Okay, then I'm also going to hide this. What have I remained with? 1, 2, 3, 2. So I'm going to write that to say 1, 2, 3, 2. It's not that I've run out of space, you guys, but you must be neat as you answer these things. Okay, so we proceed. So now from there, we've learned in mathematics how to find the determinant of 2 by 2 matrix, because this is 2 by 2, 1 2 1 2. All right, how do we find? It's by multiplying the major diagonal subtracted by minor diagonal. All right, so I'm going to proceed like A times P is equal to, all right, so we say here we are now finding so we're going to do like this. Then from there we find the determinant. So the major diagonal is this, then this is the minor diagonal. Always whatever faces this side, this is the major diagonal, this is the major diagonal, and also this is the major diagonal. All right, so I'm going to say 2 times 3 minus minor diagonal, this one minor, which is 2 times 3. Okay, then minus. Okay, let's go team. Because why have we put minus here? We are dealing with j. Here there was plus, no wonder we started with plus. Negative j is here, so we say minus. Let's proceed. Major diagonal 1 times 3, all right, minus. Okay, in fact here if you want you can even put, okay, so 1 times 3 minus 3 times 3 as the minor diagonal. Next, plus, we are dealing with k, so I'm going to say plus. Major diagonal 1 times 2 minus 2 times 3, this. All right, when I do like that, it's just the simple things. Okay, so I'm going to rub. Hope I've interrupted this from your minds, guys. Okay, or I can just proceed so that I don't confuse others. Let me write down here. So A times B is equal to this times this minus this times this. You're going to discover that here we are having 6 and here 6. So it's 6 minus 6, which is 0. So you put 0 under which letter? I. So you say I. All right. Then from there, you can even put negative here because we are subtracting here. So 1 times 3, it's 3 minus 3 times 3, it's what? 3 times 3, it's we know to say it's 9. Hope I'm right here. Okay. Okay. So this is 3, then this is 9. Okay. In short here, fetch more brackets. Okay. So here you perform the calculations. 3 minus 9 is 6. All right. So here I'm remaining with 6. So which is negative 6 to say. Okay. 3 minus 9 is negative 6. So this negative and this negative, when they multiply, we have positive. So the final answer here is going to have positive, then 6. Okay. Under which letter? J. So I'm going to put J. Then from there, I'm going to say next. So I've performed the calculations of these and also the calculations of this by saying major diagonal, the product of major diagonal minus the product of minor diagonal, then minus under J, the product of major diagonal minus the product of minor diagonal. When I perform the negative, the positive, I need to care for all those things. So here I add 0. Then after performing this, I'm having 6. Then I come here. 1 times 2, it's 2. Minus 2 times 3, it's 6. So here, 2 minus 6, it's negative 4. Okay? So negative times positive, I'm having negative. So here, this will change. Take care of the negative sign because you know negative ba pongosh ila ponyesha. So here it's negative 4. Under which letter? K. So this is what we have. Now, 0, you can ignore it. You can ignore it. Such that at the end of the day, you have the final answer as this that I'm going to write here. Hope this has been gotten clearly. So our final answer, A times B, is equal to, that 0 has been ignored. So we are going to have 6J minus 4K as the final answer, so that you are just clean. So this is how we find A times B, or rather the vector which is perpendicular to these two vectors. We proceed to another question. So question B was saying, find, or rather calculate, the angle between the two vectors. Now, when you've been told to calculate the angle which is between two vectors, you always use the scalar product or the dot product. Why do we use that? This is because scalar product is the only formula that has got the angle, or that shows the angle. Remember, we said A dot B. We said scalar product is also called a dot product, and you can see here. Then that one, the vector product, is also called the cross product, because we wrote something like this, meaning there was a cross here. This is the reason. So we are dealing with scalar product, question B, which is saying find the angle. So we are going to use the scalar product in order for us to find the angle. The formula is A dot B is equal to the magnitude of this A multiplied by the magnitude of this B, okay, in straight bars, then cos theta. Okay, this is the formula. I'm going to repeat the formula with a black marker. We are saying, in order for you to find the angle, you have to use the dot product or the cross product. The formula is here. A dot B is equal to the magnitude of B. When you put straight bars, meaning you're finding the magnitude of B, then the magnitude of A, then multiplied by the magnitude of B, then cos theta. So we've been told to find this theta, not cos, not this, and not that. We've been told to find this. All right. So what is important here is to make this the sub of the formula. Mathematically, before I even start performing the functions, let me show you how we are going to. So you make theta the sub of the formula. How are you going to do it? You divide. Okay, you divide both sides by this. So we are going to divide to say this, then this, and that, such that when these cancel, I'm remaining with cos theta is equal to A dot B over the magnitude of A, then the magnitude of B. Okay, when I remain like that, still haven't made theta the side of the formula. So I'm going to say theta is equal to cos inverse. Okay, when this one comes this side, it becomes cos inverse of this. You put now A dot B over magnitude of A, magnitude of B. So in short, this is the formula that we are going to use in finding the angle when I make that the subject of the formula. So what do we need now? We need to find A dot B. And I'm going to show you just a straight way in which to use in order for you to find this. The magnitude of A, like we did last time, the magnitude of B also last time, but we're going to go through it. You are covered, your job is just to smart. Then you punch on the calculator. It's just shift, then you punch this. So we shall stick to this formula as we find. So I'm going to rub now. First we find this, and that. Then it's just about replacing, then punching the two things there and there. You are done. All right, so let's proceed. Let's proceed. So from the formula A dot B is equal to the magnitude of A, the magnitude of B cos theta, we are going to find AB. So find first A dot B. That's the first step, number one. Let's find this because we want to find the theta, which is here. So how do we find this? There's just a simple way to use in order for you. Okay? Remember, vector A is 1, 2, and 3, meaning 1i, 2j, 3k. Then vector B is 3i, 2j, 3k. So, in order for you to find the A dot B, simply get the coefficients of this, okay, and align them accordingly. So we have the coefficient of I here is 1. So I'm going to say 1, okay. What follows? It's plus. The coefficient of J, it's 2. So I'm going to say plus 2. The coefficient of K is 3. So I'm going to say plus 3. Then we come to B. This is vector A dot vector B. Then here it's 3 plus the coefficient of 2 is the coefficient of I is 2. The coefficient of K is 3. When I make them like this, then I even do like this. Here you'll be multiplying this times this plus this times this plus this times this. This is how we simplify A dot B. Simple stuffs. So this times this, 3, plus this times this, 4, plus this times this, 9. Then you simply add this. So A dot B is equal to, when I get my calculator, just be humble. Even if these are simple calculations, just take it the calculator. So it's a 3 plus 4 plus 9. All right. What am I having? 16 on my calculator as the answer. So 16. So we know to say from these we found part A, which is this 16. You pick, or rather you keep it because it will be used later on. Then go to finding the magnitude of A. Again, you find magnitude of A, B. Then you plug in. All right. So I'm going to proceed. I've found A dot B as 16. Let's proceed. From that formula, we find A, the magnitude of this, step by step. So A is given to be I plus 2j plus 3k. Okay, this is our A. So its magnitude is the resultant. So the magnitude of this is equal to the square root of 1. Here you get the coefficients also. 1, 2, 3. 1 squared plus 2 squared plus 3 squared. All right. So when I get this, I'm going to punch on my calculator. Okay. I'm going to say, of course, we know to say 1 squared is 1. So I'm going to say 1 plus 2 squared plus 3 squared. I'm having 14. Then square root of the answer. Okay. Then I say square root of the answer. I'm having 3.7. So when I punch, I'm having 3.7. So 3.7 is the magnitude of this. I'll also keep it, then find, let me rub so that I just be clean, sharp. So 3.7 is that. Then find the magnitude of B. Okay, so the magnitude of B was given to be 3i plus 2j plus 3k. All right, this was my B. So if this was my B, what are we going to do? All right, we also find the magnitude of B, which is also the resultant. So if I want, I can even do like this, the resultant of B. So the resultant of B is given by this formula, whereby we know to say it's 3. We pick the coefficients. We ignore these letters. 3 squared plus 2 squared plus 3 squared. when I punch on my calculator, what am I getting? I'm going to say 3 squared plus, okay, plus what next? 2 squared, 2 squared plus what next? 3 squared. What do I have? I've got 22. Squaring this answer, I've got 4.69, which is 4.7. 4.7 as my B. All right, so let's now collect the data all together. From this formula, A dot B is equal to the magnitude of A, magnitude of B, then cos theta. So the data that we have obtained so far, our A dot B was found to be, so our A dot B was found to be 16. Then our magnitude of A was found to be 3.7. Then our magnitude of B has been found to be 4.7. What we need is this. Simple stuffs. So this data, then remember the formula that we had made. Okay, we said after making theta the sub of the formula, we said theta was equal to cos inverse. Okay, we had A dot B over magnitude of A, then magnitude of B. So it becomes easy. Just plug 16, you put it here. 3.7, you put it here. 4.7, you put it here. Then you punch in your calculator. As simple as that. So let's do that. Hurry up. All right. We do that. So theta is simply cos inverse. Okay, let me write it from here. Theta is equal to cos inverse. So here, what was here? A dot B. So 16, that's what we found. Then A was found to be 3.7. Then magnitude of B, 4.7. Let's now punch in the calculator. Just punch at once. Okay? So I'm going to bring this calculator here. How to find cos inverse? Those that haven't bought the calculators, please buy the calculators, because physics and chemistry, you're not going to do it without a calculator. All right, so you punch shift. Okay, when I punch shift, then I'll come on cos. I'll say cos. I've created cos inverse. Then open the brackets. Then I enter the figures. I say 16. This simply means divide by. So divide by. Then I'll say 3. I open the brackets. 3.7. Then multiplied by 4.7. Okay, so when I punch on my calculator, I'm getting something like 23.06, which is just 23. So the angle is 23 degrees. This is the angle. Simple stuffs. Just punch at once, you find the answer. That's all about it. All right, I hope there are no questions. I wish I had an online lesson with you guys such that I can even allow you to ask questions. But don't worry, we are opening soon. You know, you guys are covered. Okay, you guys are covered. All right. The last question says the unit vector. Now, by definition, a unit vector is just a vector divided by its magnitude. So if this is the vector, for example, let me just start the scenario. For example, if they tell me to say find the unit vector of vector A, okay, find the unit vector of vector A such that A is equal to 3i plus 2j plus 4k. If they tell me to say this, so a unit vector is the vector itself, A divided by magnitude A. This is the formula. This is the unit vector such that this divided by, so you're going to say 3i plus 2j plus 4k divided by the magnitude of this, which is 3 squared plus 2 squared plus 4 squared. This is simply, then you punch on the calculator, you leave it like this, then you punch. So you are going to discover that mostly it is this divided by the figure that you get from here. As simple as that. That's the definition. So what do we have here? The question is saying find the unit vector of that perpendicular when you finish the question. So unit vector will be the vector A times B over the magnitude of this. The magnitude of itself, what we found, which is, if I want, I can even say A times B. When I put in straight bars, I'm talking about the magnitude. Now remember, we had already found A times B, which is the vector perpendicular to the two vectors. Then it's just about finding now this. What did we find? Let's go back. Let me take you back to what we found. Okay? To what we found, A times B. So A times B was found to be, where is this? It's performing. Okay, I found it. So remember now, A times B. If you want, you can even rewind the video. You are going to find that A times B was found to be 6i minus 4k. Remember where we are hiding things, you hide here, you find the determinant. We found this 4j minus 4k because I was 0. This was 6j minus 4k. So we are going to use this to find this. Therefore, we are going to say unit vector is equal to A times B over the magnitude of A times B. A times B, you put just this, okay? Remember from the example that I'm just from giving you, 6j minus 4k over the magnitude of this. So the magnitude of this, you're going to simply get 6 and 4. So 6 squared plus negative 6 squared. You punch on your calculator, all right? So when you punch this on your calculator, let's proceed. I'm not going to wrap this. Assume this is the continuation of this. So when you punch on your calculator, so you'll have a unit vector is equal to 6j minus 4k over, our main interest is finding this. So when you punch on your calculator, you're going to discover that it's giving you, okay. So when you punch, you're going to have 6 squared plus, open the brackets, negative 4 squared, 52. So 52, there's no, you don't leave points and the likes. You can just write it like this. So 52. Then this is your final answer. Don't worry about this square root to say square root the answer, then you find 7 point. You can even leave it like this just to make it clear. So this was the continuation of this. Assume this was down here. So that's the unit vector. That's all. So thank you so much, guys. This is the end of PH 110 vectors. All right, remember we did units and measurement, then we are summarizing vectors. So next in physics is kinematics that we're going to start today. Thank you. Take care. See you in chemistry.